Now that we've talked about direct variation, we can talk about indirect variation. With indirect variation, as one variable is increasing, the other one is decreasing. They have an indirect relationship. It is said y varies indirectly as x if y equals k divided by x. So now we can see the variation constant is being divided by x. That is the indirect relationship. This first example says w varies inversely as d. So that's how we form our equation. So w will vary inversely, which is the same thing as saying indirectly. So that variation constant goes in the numerator, and d is what we're dividing by. So that is the indirect variation, or inversely. Then it says if w equals 4/10 when d equals 2.5, find w when d equals 4. So we plug in what we know. We know the 4/10 is w. We don't know the variation constant yet, and d is 2.5. Now, to get rid of that 2.5, the opposite of dividing by 2.5 would be to multiply both sides by 2.5. And 2.5 times 0.4 is 1. So that variation constant is 1. Then we have to find w when d equals 4. So we need to know w. We know the variation constant is 1 and d equals 4. So w equals 1/4, or 0.25 if you choose to change it to a decimal. So again, the same steps as direct variation. We have to find that variation constant, and then we can find the unknown variable for the new value. Let's look at a story problem. This says the weight of a body varies inversely, so there's our key that we know it's going to be inversely, as the square of its distance from the center of the earth. Okay, so let's break down what this says. The weight varies inversely, so that's how we know that it's going to be a division, inversely, as the square, this is important, of its distance. Okay, so that's how we're going to form our equation. So the weight, I'm going to use w, varies inversely, so k divided by the square of its distance. So instead of writing just d, I'm going to write d squared, because it said the square of the distance. Now we plug in what we know. If the radius of the earth is 4,000 miles, how much would a 125-pound woman weigh 1,000 miles above the surface of the earth? All right, we still have to find the variation constant first. So we plug in the things we do know. We know that she weighs 125 pounds. Oops, 125. And we don't know the variation constant. And this is when she's on Earth, she weighs 125 pounds. So on Earth, the radius of the Earth is the 4,000 miles. So she's 4,000 miles from the center of the Earth. And that's when she's just standing on top of the Earth. All right, so 125 equals k over, we have to square that 4,000. So 4 times 4 is 16, and 1, 2, 3, 1, 2, 3. We've squared it. Then we want to solve for k, so I need to multiply both sides by the denominator. That divides out the denominators, and on the left-hand side, I have that 125 times the 16 million, and that is a lot of zeros. 2, 3, 4, 5, 6, 7, 8, 9. So looking at that, we've got hundreds, thousands, millions, billion. 2 billion is the variation constant. Now we can figure out how much she would weigh if she was 1,000 miles above the surface of the Earth. So we want to know how much she will weigh. The variation constant is 2 billion divided by, now when she is 1,000 miles above the surface of the Earth, that means to get from the center of the Earth, she would have, so here, let me draw a little picture. We've got the Earth, the center of the Earth to the surface, we already said was 4,000, because that was the radius. And then she's going to be 1,000 miles above the surface. So how far is she from the center? She's 5,000 miles from the center of the Earth. And we want to make sure we square that distance, right? So now I've got my 2 billion divided by 5,000 squared. So 5 times 5 is 25. And 1, 2, 3, 1, 2, 3. We're squaring that 5,000. And once you divide 2 billion divided by 25 million, you should get 80. And that would be 80 pounds. So the further you get away from the center of the Earth, the less you weigh. That's the inverse variation. Go ahead and try the 2 on the right. The next example says y varies inversely as x. Again, our equation would be y equals inversely, so k divided by x. If y equals 6 when x equals 4/3, find y when x is 4. Again, first step, find the variation constant. So when y is 6, x is 4/3. Now, you don't have to overthink this with that fraction. It's k divided by 4/3. Well, how do I undo divide? I multiply by 4/3. Whatever I do to one side, I do to the other side. So multiply both sides by 4/3. I can simplify that fraction by dividing out of 3. And now I just have 4 times 2, which is 8, equals k. So you should get that variation constant of 8. Once we have that, we can find y when x is 4. So variation constant goes in the numerator, x goes in the denominator, and 8 divided by 4 is 2. So y would be 2 when x is 4. So as one is increasing in size, the other one is decreasing. The next example, the loudness L of a sound in decibels is inversely proportional to the square of the distance from the source of the sound. Alright, so that's our equation. So loudness is inversely proportional to the square of the distance from the sound. So that's our equation. So the loudness inversely, meaning k divided by the square of the distance, so d squared. Now we can find when a person is 16 feet from a motorcycle, it is 60 decibels loud, and we need to know how loud is the motorcycle 39 feet away. So this makes sense that this would be an inverse proportion, right? The further away it goes, the quieter it sounds. So it's getting less loud. All right, that sentence, when a person is 16 feet from a motorcycle, it is 60 decibels loud. So 60 decibels loud. We don't know the variation constant. and it was 16 feet from the person was 16 feet from the motorcycle. And don't forget that square. So we want to solve for K. 16 times 16 is 256. Multiply both sides by 256 to get rid of that denominator. 256 times 60 is 15,360. Alright, once we know K, we can find how loud the motorcycle is at 39 feet away. So we don't know how loud. Variation constant was 15,360, and it was 39 feet away, so 39 squared. And 39 squared is 1,521. We divide, get approximately 10.0986, and so on. And it says to round to the nearest hundredth. So the hundredths place is the 9. We look to the right. That 8 says to round that 9 up. So when we round that 9 up, it carries the 1 back over to the tenths place. So 10.1 decibels. And there you go.